This video is going to discuss adding and subtracting polynomials. If you recall, we discussed a monomial was a term that included a coefficient and multiple variables. As long as everything was being multiplied together, it was considered a monomial. In this case, a polynomial is one statement that has multiple monomials in it, separated by addition and subtraction operations. So, the whole goal for this is to combine all of the like terms, which means all variables and exponents have to be identical in order to combine them. If we look at this first example, I have negative 6x squared plus 5 is being added to negative 9x squared minus 10x plus 1. You're first going to distribute that center sign to everything to the right of it inside of that parenthesis. Now, when you're working with addition, this isn't going to make that big of a difference, but in subtraction it will. So, if you follow along, nothing happened with that first parenthesis, so it just gets brought down and rewritten. Now, when I distribute my positive sign, a positive times a negative gives me a negative, a positive times a negative gives you a negative, and a positive times a positive gives you a positive. So technically, nothing really changed inside of that second parenthesis, other than we just showed that we were distributing this positive sign. When I rewrite this, this is when I'm going to combine my like terms. When you combine your like terms, you end up with negative 15x squared, because I have a negative 6x squared and a negative 9. I get negative 10x, because I have a single negative 10x term, and I get a positive 6, because positive 5 plus positive 1 gives me a positive 6. When you rewrite your final answer, in this case nothing changes, however, you should rewrite it with the greatest degree first. If you look over here on my notes, a degree is the sum of exponents of the terms. So if I was looking at, for example, 6x squared, the sum of the exponents is just a 2. If I looked at 6xy squared, this degree is going to be a 3 because I have a 2 on this y and an understood 1 on that x. For 6y squared z to the third, this is going to give me a degree of 5 because I have 2 and 3, which is going to give me that 5. In this case, it was already written in correct degree form, so you don't need to do anything else. For my second example is the subtraction. This is where distributing that center sign is going to change some things. So again, this first parenthesis, nothing changes, so I just rewrite it down here. When I distribute my negative sign, a negative times a positive gives me a negative 4x squared, a negative times a negative gives me a positive 5x, and a negative times a negative gives me a positive 2. Now, you're going to rewrite them, combine your terms, and put it with the greatest degree first. When I rewrite things, I get 8x squared and a negative 4x squared, so that's going to give me a positive 4x squared. I have 8x and 5x, which is going to give me a positive 13x, and I have 6 plus 2, which is also going to give me a positive 8. So I don't need to rewrite anything because my highest degree of 2 is already written first. And for the last example, if I have 4v squared plus 8v plus 4, and I'm going to subtract v squared plus 7v plus 2 from that again, you're distributing that center sign and rewriting. So the first thing all stays the same. I have negative times a positive gives me a negative. Negative times a positive gives me a negative. Negative times a positive gives me a negative. So now when I combine all of my terms, I get 3v squared plus v plus 2. And since my v squared, that 2 is the highest, it is in the correct format. You can rewrite a 1 in front of the middle v if you want. However, it's not necessary. So another answer that you could have is 3v squared plus 1v plus 2. This and that mean the exact same thing, and it's not necessary if you don't want to.